Welcome everybody. Thank you so much for joining for this second webinar on cybersecurity in manufacturing. The title of today's seminar by Josh Lubell from NIST is Protecting Additive Manufacturing Information When Encryption is Futile, a case study employing NIST cyber risk management guidance. Josh is a computer scientist whose work focuses on smart manufacturing systems cybersecurity. His interests include markup languages, information modeling, and he's done a lot of work on standards development in this particular area. His baseline tailored software tool for security control selection won an award from Government Computer News. He is also a past winner of Department of Commerce Silver Medal for his leadership in developing ISO 10303-203, a standard for representation and exchange of computer-aided designs. He has won other awards, including the NIST Bronze Medal for creating data models to support lifecycle of engineered equipment, and the PDS Inc. Brian K. Martin Technical Excellence Award for contributions to the ISO 10303 modular architecture and implementation methods. So, Josh, thank you so much for coming and presenting at this webinar. The floor is yours. Please feel free to share your screen.
Okay, thank you, Jitesh, for the introduction, and thank you everyone for attending, even though it's so close to the holiday season and you've all got a lot of other things going on in your lives, so I really appreciate the attention. I'm going to share my screen now. Here it is. Okay, so before getting into the presentation, I just want to say a little bit about myself. I began working in the cybersecurity area about 8 years ago. And what I've been doing since then is been focused on developing information models and tools to make it easier to use NIST's cyber risk management standards, and particularly in manufacturing environments. And prior to working in that area, for a long time, I was active in ISO 10303, also known as STEP. And throughout my career at NIST, I've had a long time interest in markup languages, XML and its more modern equivalents, and also data models. And so my instinct is to look at, how can I make this guidance or methodology easier for people to deal with by employing markup in a good data model. And the screenshots on the right-hand side are actually from tools that I developed in the cybersecurity area over the last few years. But in this talk, I'm not going to say anything at all about markup languages or data models, but rather I'm going to talk about the cybersecurity guidance itself in the context of a very interesting attack scenario. So to begin with, I'll give a brief overview of 3 very important NIST publications in cyber risk management. One is a high-level framework. The second is a very low-level collection of security controls. And then the third focuses primarily on what's known as controlled unclassified information, or CUI, as they call it. Then I'll get into the attack scenario, which was actually mentioned by Mark Yampolsky in last month's seminar in among his many projects. And this is very interesting and groundbreaking research where demonstrating the feasibility of side-channel attack to steal information from an additive manufacturing process, even when the data is all encrypted end-to-end. And then next, I show how using the cyber risk management guidance from NIST, one can apply that guidance to come up with what to do when when encryption is futile for protecting your information and what some of the alternatives are. And then I'll conclude with some brief remarks. So to begin with, let me talk about cybersecurity and CIA, which means confidentiality, integrity, and availability of information. So basically, cybersecurity is about systems and information. And then the systems can be computers or communication systems, wire electronic communication, or even groups of computers together, or a system can even be a cloud service. And then the information is what you're concerned about protecting, in addition to protecting the systems themselves. And the three aspects of three types of ways of protecting information are protecting its confidentiality, integrity, and availability. So confidentiality means preventing unauthorized access and disclosure, and also protecting privacy. Integrity means guarding against improper modification or destruction, and also ensuring that the information is authentic and that cannot be misconstrued as otherwise. And then availability is ensuring that it is timely and can be reliably accessed. So what's interesting is that in different settings, confidentiality is paramount, but in other settings, say, availability might be paramount. So for instance, if you're maintaining a power grid, availability is really key, and confidentiality not as much, whereas in the scenario that we're going to be talking about today, confidentiality is first and foremost. So getting into now the NIST guidance that we're going to consider in this talk, the three specifications are the framework for improving critical infrastructure cybersecurity, which is more familiarly known as the Cybersecurity Framework. And then the second is NIST Special Publication 853, which is the documents all of the NIST security controls, and there are hundreds of them. And then the third is an organization, a relatively new publication on protecting controlled unclassified information in non-federal systems and organizations, which is Special Pub 800-171. And I'm going to show how these three specifications complement one another. No one does it all, but the three together can work very well. And I didn't just pick these specifications out of thin air. They're all three. They're in the top 10 of NIST's most popular technical publications in terms of download. And what this picture shows a ranked ordering, when I've highlighted what applies here. So cybersecurity white paper, that is the framework. And then 853R4, that's the security controls. And then there are two entries for 800-171, and that's because this period is over the last 2 years, 2019 to 2020, and just a few months ago, or earlier this year, a new revision to 800-171 came out. So included both the old revision and the new revision. And what these guidance publications do, in addition to helping you find a way forward, they also provide traceability, and that's very important. So what I'm showing in this picture here is that by using these three guidance publications together, you can take a high-level requirement from the cybersecurity framework and then show how a lower-level requirement from 171 satisfies that, and then yet a lower-level security control satisfies that that 171 requirement, and then the security control in turn can implement one or more different net cybersecurity security countermeasures. And note that countermeasures are not necessarily technical. So you can have, like, this is would be an example of a technical countermeasure, which is a PIV card that contains digital credentials for accessing a system or a building or whatever. But you can also have something like security awareness training as an implementation of the security control. And then what's key is that given this traceability, you can then document what you're doing in a security plan, and that shows how your implementations trace back to requirements, and it's all documented there. So now we're going to get into each of the guidance publications. So starting with the security framework, which I like to think of as a welcome mat, in that it's comprehensive yet easy to understand. So it's organized in a top-down way, and it's kind of seductive in the sense that that it's very, very simple to grasp at first, but then leads you in a lot of more technical directions. So the framework is appropriate for everyone, whether government or for profit or nonprofit. And what's key about the cybersecurity framework is that it has informative references to other specifications. So it's a good entry point for getting started. But it's too high level to stand alone on its own. So if you study it, you quickly learn that you need to study other things as well. But like I said, it's a very good, easy to grasp starting point for the big picture. And then just to get you an idea, the cybersecurity framework includes a core taxonomy of 5 high-level functions, which in turn have categories. And then each category in turn has a list of subcategories. And notice that the categories and subcategories all have unique identifiers, which get back to this traceability idea that you can, it gives you an easy way to say in your risk management process that something you're doing traces back to something in the framework. And then for each of the subcategories, there's a whole list of informative references. And actually what this slide shows is not an exhaustive list. There are additional informative references as well. And these can be sections of standards, either NIST standards like 853, which I'm going to talk about in a minute, or ISO standards or industry standards. So now moving on to NIST Special Pub 853. This is a very big specification. It has it all in the sense that it's got lots of security controls with lots of technical details, and even tells you how to adapt the security controls to your particular need, and contains includes companion documentation on doing assessments and creating baselines, which is a baseline is kind of the default settings that you can use as a starting point. So it's 853, I think of as a fire hose in the sense that it's got everything, but it's big and overwhelming. And also, yet another characteristic of 853 is that although it has lots of useful information for everybody, some of the information in it really only applies to the federal government, and non-federal folks don't need to see it. So for instance, it talks at great length about having an authorizing official for a system. And that's something that's a federal requirement, but in the private sector, you don't have the idea of an authorizing official necessarily. So that's 853. And then just to give you an idea of its complexity, this is actually one of the simpler security controls, simple enough that it fits on one slide. So as you can see, there's a short statement of what the control, then a more detailed discussion, relationships to other controls, and then an enhancement, which is kind of like an option for strengthening that control. And what's more, security controls can have parameters that are sort of like templates where you fill in the blanks. So all of that, like I said, there's a lot to it. And then the third specification is Special Pub 800-171 for protecting controlled unclassified information. And this I characterize as the Goldilocks guidance, in that it's not too high level, not too low level, and it's just right for a specific context. In this case, protection of controlled unclassified information. And so 800-171 is meant specifically for non-federal users, in particular those who are required by the U.S. government to comply with 800-171. But I think it's got a lot of useful information, even if you're not subject to, even if you're not a government contractor. And but there are a lot of certainly in manufacturing, there are a lot of companies who do contract to Department of Defense and other agencies. So this is very much important to them. And you may have also heard of a new program called Cybersecurity Model Maturity Certification, which is a regulatory thing that recently started in Department of Defense, requiring all contractors to get certified in cybersecurity, and there's a formal process and list of criteria and so on. And 800-171 is a major part of the technical underpinning of the cybersecurity model maturity model certification process. So 800-171 is very good about serving a particular need, but it focuses only on confidentiality of that CIA triad. So as a manufacturer, you need to be concerned about integrity and availability as well as confidentiality, and 800-171 doesn't address those areas really. So 171 isn't all you need to pay attention to, but it's a large part of it. So just to talk about what is controlled unclassified information, it's there are numerous categories of it, and there's actually the U.S. government, specifically the National Archives Records Administration, NARA, has a registry of the different kinds of CUI. And just some examples include financial information, critical infrastructure, personally identifiable information, agribusiness information, and then down here is something familiar to all of you, a CAD model. So proprietary product model data is a specific category of CUI as well. And that's what we're going to focus on in our scenario that we're going to be talking about. So now moving on to the scenario, and this is based on research at Auburn University that Mark talked about last month. So the idea here is that a customer is contracting with an additive manufacturing service bureau, and the customer's data is encrypted end to end. There's a secure communication between the customer and the service provider, digital rights management protection on the host computer that the service provider uses, secure communication of the toolpath commands between that host computer and an FDM, fused deposition modeling, 3D printer, and there's also, furthermore, there's a trusted platform module that limits the presence of plain text on that 3D printer. But despite all of this encryption, the contract manufacturer is a bad guy and is using an oscilloscope to interpret side channel signals from the stepper motors on the printer, and is able to achieve high accuracy from these signals, and to the point where they can reconstruct the product model. And so this is a picture of what I just talked about. So on the left, you've got the customer. On the right, you've got the nefarious service provider. And although you've got you're securing the data in transit and also the data at rest through encryption, nevertheless, it's possible using the aforementioned oscilloscope to steal that intellectual property. So some burning questions for the AM customer is, what can the AM customer do to protect against this kind of scenario? Should they not outsource, bring their 3D printing operations in-house, or maybe there's some sort of alternative to encryption that can at least partially protect their data, or maybe they just need to accept the risk of theft and trust the service provider. So what's the AM customer to do? So now what we're going to do is we're going to look at how the NIST guidance can help find answers to these questions. So starting with the cybersecurity framework, let's look at the 5 high-level functions and their categories and see which categories might apply. So there's an asset management category, which applies because that product data, that part model is an asset. Assets can be data as well as physical things. Supply chain risk management certainly applies, since we're talking about a supply chain scenario here. Data security applies, since we're focused on the security of data, in this case, I guess at rest. Also, security continuous monitoring might apply, since in an ideal world, we'd like to be able to monitor the service providers so that we would know if they were trying to use an oscilloscope to reconstruct the model data. And then the communications matter, since it would be a plus to be able to know in advance that this AM service provider might be nefarious. So now looking at asset management, what I have here is this is the definition of the asset management category from the cybersecurity framework. And then you've got 3 subcategories. And the first one says that external information systems are cataloged. So that one is where we're going to look at more closely. So what that means is that in this case, we would even before an attack, we would at least know that we would know that this 3D printer that's external to our company that we don't have control over is a thing that we need to be concerned about, and it's identified and on our radar. And so now, looking at an informative reference to Special Pub 800-171, which is the Controlled Classified Information Protection, you can see that there's a requirement from 800-171 that says to verify and control or limit connections to and use of external systems. So it's right there in 171, this particular particular threat that we're talking about. And so now what I've got up here is a discussion of this particular requirement in 800.171, and I've got highlighted here. This is my highlighting. It's not in the standard itself, but this requirement, it states in 171 that this requirement is specifically applies to the use of external systems for the processing, storage, or transmission of CUI. And so we're using this external system is being used to process CUI. In a sense, it's building a model from the part data. So it for sure applies here. And so now let's map this requirement from 800.171 to security controls. So when the 800.171 specification has handy mappings both to 853 and also to ISO 27001 in case you're not a NIST security control user, but are using the ISO standard. But we're going to take the NIST 853 route here. So as you can see, this requirement maps to the security control AC-20, use of external systems, which is part of the account management control family. And then there's also an enhancement to AC-20 that speaks specifically on limits to authorized use. So let's dig a little deeper here. Now this is from the 853 spec, and it talks in more detail about the use of external systems. And what it says is that for the AC-20, the guidance is to establish some sort of terms and conditions to be implemented on external systems, consistent with trust relationships established with those organizations. So it brings in the whether or not you trust this service provider, and then the terms and conditions apply to accessing information from the external systems, and also processing, storing, and transmitting organizational controlled information using these external systems, or as an alternative, prohibiting the use of the external systems. So that means that if you can't achieve a satisfactory protection mechanism or trust relationship, then you must prohibit the use of that system. And then the enhancement to AC-20 specifically says that talks about verifying that the external system has security and privacy policies that match your own. So what does this all mean to the AM customer? Well, one can interpret the discussion of AC-20 that to say that the customer needs to establish some sort of either terms or conditions or security controls that are consistent with how much the service provider is to be trusted. And what this means is that the more critical that STL and toolpath data is, the more trust is required. So for instance, if the manufacturing taking place is relatively low value to the point where it's not worth the service provider's while to actually go to the trouble of stealing the data using side channel analysis, then it may not be that big a deal. On the other hand, if the data is very, very critical data and has a lot of value, then that's a different story. And in that case, not outsourcing might be the best option. And then interpreting what 853 says in in the enhancement to AC20, here, the interpretation could be that that we want to make sure that the service provider has implemented whatever service security controls are needed for our comfort level. And one consideration is, is it how malicious is the service provider? Is it okay as long as they can protect against an insider threat, or is the service provider rotten to the core in the sense that that the malice is leadership orchestrated, in which case insider threat protection would not be enough. So, so I just talked about guidance from 800-171 specific to CUI, but now I want to spend a couple of minutes just talking about other kinds of guidance that that go beyond that. So so now we're going to look at the cybersecurity framework, and we're not going to dig into the depths of 853 in the interest of time, but to do a more thorough analysis, it would be necessary to do that. So just to give you an idea of some other sources of guidance that we can get to from the NIST risk management specifications. So looking at the supply chain risk management category from the framework, in this case, there are 3 subcategories that are applicable. And the first one says that that suppliers and third-party partners of information systems, components, and services are identified, prioritized, and assessed, and use a supply chain risk management process. And the second one says that contracts with these suppliers need to be written such that that they're required to follow these practices. And then the third subcategory provides for auditing and testing and other forms of evaluations to confirm that they're meeting what the contract says. So what this means is that this tells us that we want to be able to assess the supply chain risk of the provider and this external FDM printer, and we want to make sure that the contract relationship we have to them encodes the risk mitigation measures stated here, and we also want to have the ability to conduct audits, without asking for that privilege in advance. So these would all be things to do that would help to ameliorate the lack of the ineffectiveness in this case of encryption to protect it against the problem. Now looking at another the security continuous monitoring category in the cybersecurity framework. Here, there's a subcategory that specifically speaks to monitoring that service provider activity. So here, if we're going to monitor their activity, then how do we do it? Maybe unannounced inspections or stationing personnel at the service provider's facility. Those might be possible options. On the other hand, it may also mean that it'd be more practical just to not outsource the 3D printing. And then lastly, looking more deeply at the communications category in the framework, there's a subcategory that specifically calls out voluntary information sharing with external stakeholders. So here, this points to the option of information sharing as a way to reduce to help protect against the threat, or also help respond to it when it occurs. So the idea here is to is to have some knowledge about this service provider from the perspective of other customers. Have they recently had IP theft or counterfeiting? And also, or maybe there's another service provider who's more trustworthy that we can switch to instead. So these are things that can be discovered through better communications. So in conclusion, what I'd like to say is that I hope I've demonstrated how the cybersecurity framework 853 and 800-171 complement one another, and that together can provide a path toward implementing security measures, but whether they're more technical measures like encryption and more people-based measures like awareness and communications and maybe contract language, etc. But that they can provide a roadmap toward implementing the right security measures to fit the business requirements and the risk appetite for a scenario of any sort. And also, I think an insight from is that sometimes the best option is to accept the risk if the risk is acceptably small. And lastly, I want to make the point that security is not just technology, it's technology plus people, plus relationships, plus planning. And sometimes the technical measure, although the technical measures are great when they're applicable, sometimes they're not. Sometimes encryption can be futile. And in this case, and in other cases, people, trust, and relationships matter. And often you need compensating controls when technical countermeasures fail. So these specifications all help you figure out what to do when one option doesn't work and another option might. So that's the end of my talk, and hopefully I have time to answer some questions. And thank you for your attention.
Thank you so much, Josh. Really appreciate it. We can open this up for discussion. We do have time. So please feel free to unmute yourself and either ask the question or highlight any points that you would like. So while people are, doing that, Josh, I had one quick question about the cybersecurity framework that you presented.
Yes.
What is the current state of development? Is this an ongoing development initiative, or does it reach a stable state and then it's available for everybody to use? And are you thinking about adding more technology-specific recommendations, like for different types of AM technologies? There may be unique, approaches that could be adopted. So, is that something that comes under this framework?
To answer the first question, the framework, it's a living document, and the current revision is 1.1, and it gets revised every so often. But even in absence of a revision, the informative references are very fluid in the sense that I didn't talk about this today, but there's an online informative references catalog, and anybody who wants to can apply to be included in that catalog. And NIST has a registry of these informative references.
Okay, great.
So using the online informative references catalog, you can refer to just about any guidance where the authors have filled out the form to get on the registry.
Yes.
And then the second part of the question was about more targeted guidance, like specific to the additive manufacturing. And the answer to that is, again, something I didn't cover in this talk. something I didn't cover in this talk is that the cybersecurity framework core is one part of the framework. The other part of the framework is this notion of profiles. So you're encouraged to use the framework to create what's known as a profile for your specific use case or scenario or industry sector. And people have developed profiles for various targeted applications. For example, NIST has a manufacturing profile, which is very broad. What it does is it adds some additional guidance to the cybersecurity framework that makes sense for might make sense for manufacturers of all types. And then you can go more targeted than that. You could have a cybersecurity framework just for additive manufacturing cybersecurity. So it's certainly doable. Nobody's done it yet, but there's kind of an infinite possibilities of targeting these things to be more specific. And the other way you can make it more specific is to actually talk about implementation. And so, for instance, you could, in your framework profile, you could talk about specific technologies and specific commercial products that you might want to use to do a certain thing. Mm-hmm. So that's definitely something that these specifications are intended for.
Thank you, Josh.
Hi, this is Adam from Purdue.
Hi,
thank
Adam.
you. Hi, thank you so much for the talk. So I just had one question kind of regarding trust, which is a big theme in this talk, and just a very complicated and kind of squishy concept sometimes. I was just wondering if there's any guidance out for sort of specifying how you feel about trust in maybe a new vendor or someone that you've been working with, or an organization that you've been working with, for when you're actually tackling these different control measures that you mentioned. Is it more subjective, or is there any guidance on sort of formulating specifically how you should think about trust when you're looking through these documents?
I think it is kind of a more squishy sort of thing, and I think it's particularly an issue for additive manufacturing, because one of the selling points of AM is that so much of the complexity is in the design data that makes it easier to switch providers, unlike in, say, subtractive manufacturing, where there's a sequence of processes, and it's more difficult to make the switch from, say, one contract manufacturer to another. So I think moving forward for additive manufacturing, it's going to be yes, I think that's a very open question. Is how do you know whether to trust a service provider when when you have the freedom to change suppliers and the relationship is more transitory. And I guess it's more like what you have to deal with if you're using say a cloud service or something like that. And I mean, looking at cloud services, I don't know if you're familiar with FedRAMP, but FedRAMP is a big program that the U.S. federal government uses to vet cloud providers, and it's been very successful to date. But there's a lot to it, and it took a lot of thought and a lot of both technology and strategy to get it to where it is today. But it's enabled the federal government to use the cloud for a lot of things that 10 years ago we would have had no clue on how to do. So it's possible, but it's a big issue, and I think to get to that point in manufacturing, there's a lot of work to be done.
Thank you.
Hi, Josh. Yeah, thank you for the presentation. Just a continuation, a discussion, the trust. You had a good point here in the final slide. The trust, it's about the trust, it's about business or personal relationship, especially like the supply chain aspect and in trust. How to quantify trust, as you mentioned, is also how to measure and how to compare. So one entity is more trustful or more trustworthy than another one. How to quantify the trustworthiness. I think that's also another interesting research topic as well. I remember NIST just probably early this year or last year published a guideline for cyber physical system trustworthiness white paper or document. I think that could be interesting, maybe for all of us to read more as well. My question related to this one, as a matter of fact, is you mentioned there's a very nice idea about using TPM, which is Trust Platform Module. People use in computer nowadays already. Are you aware anyone or any vendor for additive manufacturing, the printers? Anyone already embedded those already?
My understanding is they have, and that's part of what motivated the scenario I talked about, is that that research was actually conducted using a pretty low end enough so that a consumer can buy it FDM printer that actually has the TPM as part of the hardware. So it's there, just like the Windows 10 computers have make use of the TPM.
I know that GE is working on integrating TPM in the metal 3D printers. I'm not sure about polymer 3D printers.
I see. No, it is relatively cheap technology nowadays compared to say 15 years ago when it was started, TPM. So yeah, I think that could be a very good enhancement. At least we can improve the perception of the trustworthiness for our printers.
Yeah, there's this notion of roots of trust in Internet of Things, where if we could somehow get to the point where we trust a component of an IoT device, then it's easier to trust the whole device. And this definitely applies in mobile phones, where
right.
We want to get to the point where it would be great if you could use your personal cell phone in your organization and have that be able to plug into the network and be able to just use it. And like at NIST currently, I have my personal cell phone, but if I wanted to have a cell phone for conducting this business, I wouldn't be able to use my personal phone to do that. I'd have to have two different phones. So for a while now, there's been talk about being able to bring your own device. And I think roots of trust would have to move forward in order for that to become a reality.
Josh?
Yes.
Good talk. I'm wondering what about, especially Jan asked about trust, but what about long shot? Some service providers that is acting completely benign for a long time and waits for a big contract from, I don't know, DoD or similar organization.
Mm-hmm.
So is there a way to address this, or is it just we are on a lost post? What do you think?
I mean, maybe trust but verify. I think that this could be maybe where the communications and threat information sharing part comes in. That if you have good threat intelligence, then you might hear through your communication channels to watch out that there are signs that this supplier, even though they have not been caught doing anything bad in the past, that they've been doing some suspicious things lately. So I think that's where I think that's maybe why there's so much interest now in threat sharing technology, and like in OASIS, in the OASIS Standards Development Organization. There's you're seeing more standards efforts in that area.
Yeah, thank you.
Tony, please go ahead.
Yeah, good morning or afternoon, I'm not sure. But hey, Josh, great job on the presentation, and it sure is sparking a lot of ideas about this whole, physical and guidance on cybersecurity for additive. I think one of the issues, we're talking about trust and all that is the consequences, right? I mean, for a vendor, maybe we should expose more cases on people that have been caught and what are the consequences on that. I mean, if we're going to be an IP police, there's got to be a framework for that as well. How do you report it up? Once you identify it, what are the consequences? That type of thing.
Mm-hmm. Yes, that's a good point.
Yeah, Tony raises a good point there, but I think the other thing is if we look at least on the defense side, right, the DFARS and all that with the contract languages, that's not a technical problem. Right? There's a lot of law and policy that needs to be changed to enable the reporting and the proper visibility in the supply chains and such. Right? And so I think that's why a lot of folks are looking at what are the technical solutions, because the technical solution may be easier than the policy change or changing the statutes.
Yeah, I agree. I also think I think this also raises the issue that there needs to be a higher level of cybersecurity literacy among the people who run our government and who make policy.
Yeah. Well, and I would.
I'd love to hear.
Yeah, no, I'd recommend people take a look at the Solarium Commission's report, and they just had their advanced manufacturing white paper that came out a couple of weeks ago, because I think there's a lot in there that members of Congress have recognized as issues. The problem is, no one's really got a good solution yet on how you convince the companies to participate.
I think that being able to talk about this stuff in a way that reaches policymakers is very important.
Thanks, Thomas. I just put in a link for the Solarium report. I just want to make sure that that's the right one that you are referring to.
Yep, that's it.
Wonderful. Thank you.
Yeah, thanks, Tom.
Okay, any other questions or point for discussion? We just have a couple of minutes left. If not, I would like to really thank Josh for the wonderful presentation, for sharing the insights about the framework. And I would like to thank all the participants for the engaging discussion and taking the time out of their busy schedules. Our next webinar will be in January, towards the end of January, and we'll be sending out the details of that pretty soon. So thank you, everyone, and happy holidays to all.
Thank you, and thank you, Jitesh, and thanks everyone for listening, and happy holidays and best wishes for 2021.